CISA added a Linux vulnerability to its Known Exploited Vulnerabilities catalog. That's not a press release. That's a federal agency saying they have evidence of active exploitation in the wild, which means someone is already using this against real infrastructure right now. The vulnerability being tracked is being called CopyFail, and it affects major Linux kernel versions. The CISA warning puts it in the category of bugs that federal agencies are required to patch within a defined remediation window, typically 21 days for known exploited vulnerabilities under Binding Operational Directive 22-01. If you're running Linux servers, which statistically describes almost every backend stack in production today, this is not a wait-and-see situation. Let's be precise about what we know and what we don't. The name CopyFail appears to relate to a flaw in how the Linux kernel handles copy operations, likely in memory management or interprocess data transfer. The specific CVE identifier wasn't clearly surfaced in the reporting I'm working from, so I'm not going to invent one. What is clear from the CISA advisory framing is that this is a privilege escalation or remote code execution class vulnerability, because those are the categories CISA consistently flags as actively exploited at this severity level. If it were just a denial of service, the language around major risk to servers and data centers would be overstated even by government agency standards. Here's why the actively exploited designation matters more than the CVSS score alone. A vulnerability can sit at CVSS 9.8 for months with no real-world exploitation. Vendors patch it, you put it in your normal patch cycle, life goes on. The moment CISA says actively exploited, the threat model changes. It means exploit code exists and is being used operationally, not just by nation-state actors with 0 days they're hoarding, but likely by criminal groups who have either independently developed or purchased working exploits. The window between CISA KEV listing and commodity exploit in ransomware toolkits is historically very short, sometimes measured in days. Which Linux versions are affected? The reporting describes it as major versions, which is frustratingly vague. Given the kernel's architecture, vulnerabilities in core subsystems like memory management, the VFS layer, or network stack frequently span multiple kernel versions, sometimes going back years. Ubuntu LTS, RHEL, Debian Stable, and their derivatives all ship different kernel versions, but they all backport security patches from upstream. The practical implication is that you should not assume your distribution is safe because it's not running the absolute latest upstream kernel. Check your distro's security advisory page directly: Red Hat Security Advisories, Ubuntu Security Notices, Debian Security Tracker. Each will tell you whether the patched package is available and what version number fixes it. Container environments deserve a specific call-out here. If you're running Kubernetes on Linux nodes, and most people are, the kernel vulnerability lives on the node, not inside the container. Your container image could be perfectly up to date, and you're still exposed if the underlying node kernel is unpatched. This is a gap that catches teams off guard because their container scanning pipelines don't inspect the host kernel. Your node OS patch cycle is a separate concern from your image build pipeline, and this is a good reason to make sure both are actually functioning. Cloud-hosted infrastructure is not automatically safe either. Managed Kubernetes services like EKS, GKE, and AKS run on Linux nodes, and while cloud providers typically push kernel patches aggressively, node pools don't always auto-update without your involvement. On X, for example, managed node groups can be configured to auto-apply security patches, but if you're running self-managed node groups or using a custom AMI, that's on you. Check your node AMI versions against AWS's published security bulletins. Same logic applies to GKE node images and AKS node pool OS versions. Now, a word on the reporting itself. TechCrunch's piece is essentially a translation of the CISA advisory into consumer-readable language. That's not a criticism, it's just context. The original source of operational truth here is the CISA Known Exploited Vulnerabilities catalog at CISA. gov/Known Exploited Vulnerabilities catalog, and the upstream Linux kernel security mailing list. If you're making patch prioritization decisions, go to those primary sources. The press coverage tells you this is serious. The CISA entry tells you the specific CVE, the affected versions, and the required remediation date for federal systems, which you can use as a benchmark even if you're not a federal agency. One thing that's unclear from the reporting: the initial infection vector. Is this exploitable remotely over the network, or does it require local access first? That distinction matters enormously for your threat model. A remotely exploitable kernel bug in a public-facing server is a 5-alarm fire. A locally exploitable privilege escalation is still serious. It's the classic second stage after an attacker gets a foothold, but it changes how you prioritize compensating controls while patches are being deployed. I don't want to guess at the attack surface when the reporting doesn't specify, so check the CVE details directly once you have the identifier. Compensating controls while you're waiting to patch. If this is network exploitable, tighten your ingress rules aggressively and audit anything listening on non-standard ports. Enable audit or your equivalent logging to watch for unusual privilege escalation patterns, SEDUID execution, unexpected writes to /etc/passwd or /etc/sudoers, processes spawning from unusual parents. If you're running an EDR tool on your Linux hosts, make sure kernel-level telemetry is enabled. And if you have hosts that genuinely cannot be patched immediately due to application compatibility concerns, consider whether they can be isolated from broader network segments until the patch window opens. The operational takeaway is straightforward. Pull up your Linux host inventory today: physical servers, VM, cloud nodes, container hosts, everything. Cross-reference the kernel versions against your distro vendor's security advisories for this CVE. If patches are available, schedule them within the next 48 to 72 hours, not your normal monthly patch cycle. If patches are not yet available from your distro vendor, implement network-level compensating controls and increase monitoring sensitivity on those hosts. Document what you did and when, because if this ends up in an incident investigation 3 months from now, you want evidence that you treated it as the priority it is.